Hi everyone, and thank you for joining us for today's webinar on building and deploying Python code in Snowflake. I'm Katie D, online and social media editor at SD Times, and to kick things off, I just wanted to mention a few quick housekeeping items. This webinar will be recorded and available for on-demand viewing on sdtimes.com around 24 hours after the session. We will also be accepting live audience questions that will be answered throughout today's talk, so feel free to send any questions that you have through the chat. Today we will learn about what Snowpark is and how to build with it, how to use Snowpark in a machine learning workflow, and how to access demo code and other technical resources. To dive deeper into this topic, let's turn it over to today's speakers, Julian Forero, Senior Product Marketing Manager at Snowflake, and Caleb Baechtold, Field CTO at Snowflake. Thank you guys so much for being here today.
Hello everyone, and thank you for joining us today on this session where we're going to talk about how to build and deploy your Python code directly inside Snowflake. Many of you may be familiar with Snowflake as a SQL engine, and so we're going to tell you how you can expand that and use it to leverage Python code. To do that, just so you know, today I'll be presenting the first part. So my name is Julian Forero, and I'm Product Marketing Manager for Machine Learning and AI here at Snowflake. And then Caleb is going to come in from our Field CTO office and give you guys a demo of how exactly all of this works for data engineering and data science workloads. I'll be available. This recording will be available after the session, so you'll get a copy of that. Just so you know, what are we really going to go over today? So at the end of the day, you have a few takeaways. You'll be able to know how to leverage the Snowflake platform for data engineering and data science. And specifically, you'll be able to see how you can bring SQL and Python workloads together to streamline your architecture using this new feature in Snowflake called Snowpark. And you'll be able to even see how you could build an end-to-end machine learning workflow with Snowflake, as there will be a demo that will show you how to do this once we do an overview of all these features. So for those of you that may not be familiar with Snowflake, Snowflake is a data cloud. And what does exactly that mean? Well, there's two parts to the data cloud. One is the platform that supports a wide variety of workloads through some core components, including a data warehouse, a data lake, and a unit store, which is something new that we announced, which allows for transactional workloads all to work along with analytical workloads on the same platform. And all of this sits on this cross-cloud grid, which sits on top of the three major cloud providers, AWS, Azure, and GCP. And so really you have this one single place where you can get all your data, regardless of what cloud you want to use, and be able to process it to derive value through different workloads. This could be data analytics, things like doing dashboards and BI, or even more advanced things like data engineering and data science. And so that's a platform that supports sort of the data, call it storage, process management, access, and all that stuff. But then there's all these other content that's available as part of that. This is because as part of the Snow Grid, you have access not only to your data, but you can easily connect to third-party data. So this could be data that's available through our marketplace, or it could be partner data. You can share data with your ecosystem of business partners to get more value to your joint customers. And of course, there's different SaaS application data and customer data and other applications that you can link to the platform to really get that full view, 360 view of all your data, whether that's for a customer, an asset, or something else, and derive value from it. Now, as I mentioned, under the hood, we have the ability for you to bring all the data. This could be in any form or structure. Many times you call it structure, think of like tables. Semi-structure, these are like strings, like JSON files, XML, things like that, and unstructured. So now this platform can support all your data types. And then once they have your data here, you can process it in using this intelligent infrastructure. What it does is that as a user, you don't really have to worry about scaling it or doing tuning or anything like that. The infrastructure handles pretty much all of that for you. So it makes it easy for you to focus on building and rather than managing infrastructure. And of course, the storage is optimized. You get the best price performance for a lot of different use cases so that you can, again, focus on building and not thinking about, hey, how can I reduce storage costs and things like that, because we're handling a lot of that under the hood. And of course, at the end, what's important is how do you turn data into value? And so this is where all the different workloads come in with different set of features that enable you to generate insights, predictions, And through our application workload, you can even monetize the stuff that you built. Because we do have a marketplace where you can access third-party data and applications, you could become one of those providers by monetizing your data in a way that you can do that and share it easily using the Snowflake platform with either existing business partners or third-party customers that you have access to now through this data product technology. And so to get to the meat of what we're going to talk about today, right, is this mix of SQL and Python, very popular among data engineering, data science. And in today's world, it looks something like this, where you have cloud storage that maybe keeps a lot of your data, right? We talked about being able to support structured, unstructured data. Cloud object storage has been sort of like the way in which it's been handled today. That data has been passed onto an engine such as Spark, where you can run either Java code or Python code, and different users are going to run that in different clusters, different environments that are being managed, secured, and all that stuff. And so there's all the infrastructure management related to that. And then if they want to use SQL, now you have to not only new cluster, in addition to the Java and the Python one you had, to run your data warehouse, which is now going to run SQL. And across all of these, you're just moving data around all these environments, trying to keep up with the data security across all of those. This creates challenges around, right, separate processing, complexity and capacity management, tons of data movement, generating new silos in the cloud as you're copying data to all these different environments. And then of course, there's all the governance controls and security loopholes that come out of that. And so this is why Snowflake developed Snowpark. So what we ended up doing is we took the SQL engine and now extended it to a lot more languages. This includes Python, which is in public preview as of June. And then other languages like Java, Scala, and even some JavaScript for those JavaScript users out there. What this enables you to do is, so first you get to streamline your architecture, right? You don't have to copy data and have all these different clusters in which you're processing your data. You can have one copy of the data and let anybody process it regardless of what language they want to use. This also gives you the benefit of, by leveraging that intelligent infrastructure that I talked about, you can build scalable and optimized pipelines. So using our superior price performance and near zero maintenance, again, the focus becomes on turning data into insights and not managing the infrastructure that enables that. And of course, you can act with confidence on all this because by having a single platform, you can enforce consistent enterprise-grade governance and controls across all your workflows, whether it's analytics, data engineering, and data science. And so then you end up with something like this. Snowflake is built on top of cloud storage. And so what you're doing is now you don't have to bring data into a separate platform. Snowflake bridges the cloud storage with your processing environment. So you can have SQL, Java, Python all running directly inside Snowflake and all with a single set of user credentials that enables them to use one or more languages, right? Now you don't have to set up separate infrastructure and clusters and governance for each language. Now you can do all of those on a single platform, all on top of the same data. So of course, a lot more streamlined, simplifies all the infrastructure management. At Snowflake takes a lot of care of that. And then of course, consistent governance security policies, which become critical as you move large volumes of data into production environments. And so how does Python actually work inside Snowflake? So like I mentioned, we announced the public preview, which means it's available to everybody. We'll have more news around GA coming soon. But of course, this becomes a new language that's available and super popular among data engineers and data scientists. As part of the public preview, here's pretty much what Snowpark does. One, it gives you these familiar constructs that you can use. So using data frames, you can interact with your data in Snowflake. So you don't have to write SQL to do any data pooling, transformations, or anything like that. Using familiar data frames, maybe you're familiar with Pandas or PySpark, it's going to be very similar to that. And then one of the biggest benefits of Snowflake, or of Python, I should say, is its open source ecosystem. But the hardest thing about the open source ecosystem is how do you actually make sure that you're not bringing in a lot of erroneous code or dangerous code into your platform. And so a lot of times data scientists or data engineers may play with some Python libraries in their development environments, but then they can't bring that into production. And so that takes a lot of recoding. What we've done is we've partnered with Anaconda, who provides a vetted repository of libraries available directly inside Snowflake along with a package manager, so that you don't have to worry about any of that. So for the most popular set of packages and libraries, those are available directly inside Snowflake, and they've been vetted through the Anaconda channel. So we have a partnership with Anaconda that brings all those vetted libraries into the Snowflake platform. And then of course, because this is all running directly inside Snowflake, there's a Python sandbox that's built directly inside Snowflake so that you can run your code with a secure and sandbox environment that makes it a lot easier to bring Python code into production, which is a big challenge today. And so to get a little bit more detail, what ends up happening is really for Python, you have three big pieces to it. One is your data frames or your client API. So if I'm working, let's say I don't have to work directly on top of Snowflake, I could set up my own client. So think of it like a Jupyter Notebook or a VS Code. I can set up, connect with Snowflake, and then through that, I can do all my data transformations while working on that client, but pushing them down into the Snowflake engine. So I can do very, very large data processing. So without data movement, but working from my environment of choice. And that's what the data frame querying and stuff will do from the client side. On the functions, the other pieces are the functions and the store procs. Functions enable you to bring custom Python code into Snowflake, and store procs enable you to package that code, whether it includes a data frame, a function, both, or some of that, in order to package it and turn it into an automated piece of code. And so think of it like this, right? I write a data frame that can create a transformation that turns a set of data into an aggregated value, purchases for the last 7 weeks. As part of that, I use a function that helps me mask PII data on my table. So I don't want to see the social security for those customers. And so I have a function that masks that so that data scientists don't see that. And then in order to put this pipeline into production, I actually wrap it all on two store procs. One that masks the PII on that function, and then another one that provides those data frame queries transformations. And all of this is running directly inside Snowflake, even if you're working from an external development environment. Like I said, think of like a Jupyter Notebook, a VS Code, PyCharm, or any other client that runs the Python version that we're currently running in Snowflake. And if at any point in time you need to use Anaconda packages, then all of that is available directly inside this Snowflake platform as well. And not to go too deep into this, but as you think of like the data science workflow in terms of preparation, there's features that we have available for that, including zero copy clones, which enable you to take production data, create a clone of it, and play around with it without actually disrupting anything that's in production. And so it's a really cool feature to build your training data sets. When it's time to build, you can use also the store procs to train models. So you can package that code, bring it to Snowflake, run all your training inside Snowflake. And we've actually launched in private preview a new set of instances called with our larger in memory. And so training is a memory intensive job, and the existing infrastructure wasn't supporting large data sets that we want to train inside Snowflake. So now we have that available as well in private preview. If you want to do something like GPU based or distributed based training, we do make it really easy to bring your data into your environment using a Python connector that parallelizes the way in which you transfer data, so it makes it really fast to transfer data into your training environment. And of course, you can either train the model inside Snowflake, or if you train it outside, what you can do is package that model as a Python function or a user-defined function, and now you can run inference directly inside Snowflake. So it makes it really easy to combine your automated data pipelines that you've now orchestrated using store procedures and do the scoring of the data using the user-defined functions. We also have this new capability, so for those that are maybe more like looking for a fast-paced approach to build and deploy machine learning models, you can do that all using SQL. So we've launched a predictive feature called SQL ML, which allows you for this first phase to do forecasting type of models. So using a SQL function, you can do forecasting, and the model itself will take a lot of the data cleanup, seasonality, and all those things that maybe a data scientist would want to do custom, but an analyst wants to do a quick analysis. And so we also have a feature for that. And if you do need to run any real-time inference or like online inference, Snowflake today only supports batch inference, and this could be batches in terms of like half hours or hours, so or even in minute intervals. But if you need something that's super low latency, what you can do is you can leverage your data in Snowflake, and using external functions, you can point that data into an external environment like a Docker container or something like that, where you may be running model inference in real time for some of your real-time applications. And the coolest thing about all this is that Snowpark is integrated into a lot of third-party tools, either through the Snowpark client API that you can download, and it's open source, so you can contribute to it. So through SageMaker, you could just run your notebook there and connect to Snowflake using the Snowpark API and do all that push down that we discussed earlier. We'll actually see how this works on SageMaker Studio Lab in a demo in a little bit, but you can do this through a bunch of platforms that have partnered with us to provide this Snowpark API, client API, directly available in their services to make it really easy to build, deploy models directly inside Snowflake so that it keeps data secure and you have access to all the flexible and intelligent infrastructure that requires limited scaling. And so with that, I just want to say, here's a highlight of all the different partners that we have, not only across data science, but data engineering, business intelligence, both for Python as well as for other languages. So we have other partners that don't have a Python integration, but they have integrations with Java or Scala. So what they're doing is building code on their side, and to make it really efficient to run for you as a customer and give you a great experience, they're running that directly inside Snowflake. Now that you have a quick idea of what exactly Snowpark is, how we run Python directly inside Snowflake, I'm gonna invite Caleb to give us a demo of this end-to-end machine learning operational workflow using Snowpark, Apache Airflow as an option of something that you could do on your account, and then Streamlit, which is something that we recently announced that we acquired, and so it enables you to build applications using nothing but Python. With that, Caleb, why don't you get us started with the demo?
So first things first, I'm going to give you a little bit of a preview of kind of what the end result of this demo is going to look like. So as I mentioned, we're very much building a complete end-to-end ML ops sort of workload, all the way from database construction to data loading and feature generation, model training, prediction, model evaluation, and then presentation all the way back. And this is all going to be orchestrated using Apache Airflow. Very much covering sort of the whole ML ops lifecycle here. This is going to be a very complex sort of demo, and I'm not going to, as we go through this, really dive into the nitty gritty of the code syntactically or anything like that. My goal is really just to kind of talk through what's happening at a high level. What are the various kind of Snowpark and Snowflake features that are being leveraged along the way. But the good news is that this demo has been published to our quickstarts.snowflake.com site as machine learning with Snowpark Python. We also have our getting started with Snowpark Python quick start there for the kind of 101 level version of this sort of demo. But this particular one is also published as machine learning with Snowpark Python. And so you can always go to our quickstarts.snowflake.com and pull up this quick start and do a full walkthrough kind of at your own pace of everything that we're going to build today. Along the way, we're going to be doing tasks associated with, again, data engineering, data science, ML engineering, ML ops, orchestration, visualization, kind of the whole gambit of stuff along the way. So a lot of content here. We're going to be using, as I mentioned, both Snowpark, the client data frame API, as well as server-side runtimes to deploy and operationalize our Python code. We're going to be using a lot of other kind of non-Snowpark Snowflake internals like zero-copy cloning and object tagging and things like that as well along the way. But primarily the goal of this is to sort of show the art of the possible as it relates to Snowpark Python for data science and machine learning specifically. So again, please, after this session, go back, take a look at this quick start, walk through it yourself. We've got links to the source code and all the relevant stuff that you're going to need along the way. Sort of just to establish some context before I jump in, the example use case is leveraging our city bike dataset, which you may have seen in some previous Snowflake demos. The city bike dataset is basically a set of individual trip level data. So you'll have that a customer took a particular ride at a certain time. They started from a specific station. They ended at a different station. There's some geo information and then also information about the members and riders themselves. We've already kind of packaged up and made this data available in an S3 bucket, the same way that you might have data landing in your S3 buckets today to be able to use. But the end objective here is that we want to be able to predict what rider demand will be at the various stations throughout the city bike network. You can think of this for why this would be useful for many different reasons, both in terms of like demand forecasting and revenue, as well as maintenance teams and operations teams to ensure that there's the needed requisite number of bicycles are available on any given day, all that sort of thing. We are going to kind of make a couple assumptions in the course of this demo as well. First is that we want our development teams. This kind of project would be very much a collaborative one in the real world, right? So we want to ensure that development teams can use their tool of choice. One thing that's nice is Snowpark Python can be used in any environment that you have a Python kernel. There's no real restrictions. So I'm going to be working primarily in SageMaker Studio Lab here, but you could also be working in VS Code or IntelliJ or Eclipse or just local Jupyter and a VM somewhere. It doesn't really matter. Snowpark Python can run anywhere, and so everything we're building today could be built in any other sort of environment. Additionally, we're going to make some restrictions around data governance. So data governance and security are a huge reason why customers kind of love Snowflake already today. But as we talk about Snowpark for Python, data science, machine learning, that kind of area gets a little more complicated and has to be accounted for too. And so one thing that we're going to ensure is that there's no local storage of data. All the data is going to reside in Snowflake directly. Obviously, it's starting in S3, but once we ingest it into Snowflake, it's going to stay in Snowflake. So we're going to store, there may be temporary storage along the way, but in production, there's going to be no kind of preserved intermediate data. The other thing is that we're going to push down all of our operation at the production level on the data itself, be it feature engineering, model training, model evaluation, etc. We're going to bring all that code to the data using the Snowpark Python server-side runtime. The other piece is we're going to have to automate this. So we want the final product to be fully automated and orchestrated so that at the end, it's you have this well-documented modular code that can be deployed and managed and orchestrated using a company's CI/CD frameworks and orchestration tools. And we also have this restriction around traceability. So we need to retain information about what data was used to make what forecasts and what did the training data set look like, and that all needs to be easily accessible and retained along the way. Sounds like a lot, but as you as machine learning professionals know, this is all pretty standard stuff that you have to think about when you're thinking about end-to-end operational machine learning pipelines. And what we're excited to show today is the way that Snowpark Python specifically helps to solve for all of these various pieces. So, Snowflake customers are already used to the simplicity and scale and performance associated with Snowflake for SQL type workloads. And the same will be true for Snowpark Python workloads, and that certainly opens up a lot of opportunity in terms of data science, machine learning, and AI. So, as I mentioned, we always have this quick start you can go back to for anything that you need to look up or get confusing or to revisit later on. But to go ahead and get started, I'm just working in, as I mentioned, SageMaker Studio Lab. I've got all the relevant code and repo cloned here. I've got a Conda environment set up that's got Snowpark Python client installed in it. And that's all we really need. We're ready to go at that point. Initially, we have some basic setup type stuff here up front. So this state dictionary is going to be a JSON file that we use to retain some things along the way, such as account credentials, information about the various warehouses that'll be used, locations of data shares and things like that we're going to incorporate later on down the road. An important thing to note is we're going to be using a number of different warehouses along the way. So the bulk of our work we can do in an extra small warehouse, but the same way that SQL workloads can take advantage of hot, on-demand, immediately scalable, and isolated compute, we're going to do the same for our data science tasks. So for feature engineering and model training, for example, we can size up the warehouses as needed on demand to ensure that we can satisfy the relevant performance. Up here up front, we're just, again, going to do some initial work to establish our Snowpark session. So much in the same way that you work with other databases maybe today, everything in Snowpark Python relies on, from the client side, having the session object, which is what's going to allow us to create Snowpark data frames and then perform and push down transformations and things like that into Snowflake Compute. This next step here, we're just going to create a kind of data scientist user type role that's going to be used throughout the rest of the lab. We're going to grant them the necessary permissions that they need, and then we're going to create all the relevant warehouses, as I mentioned. The same way that SQL runs on warehouses today, everything in Snowpark Python runs on a warehouse as well. So there's no additional cost or computational framework or anything like that for Snowpark specific that's not already available to you today in Snowflake. The real kind of value add from our perspective is the bringing the extensibility and expressiveness and rich open source ecosystem of Python to Snowflake and to Snowflake customers. But otherwise, we're going to be using virtual warehouses in our Snowflake account, just like we do for our SQL workloads typically. And then we'll just update a few things in that state dictionary and dump that out for use throughout to kind of maintain state and information about our account and things like that we'll just use throughout the rest of these notebooks. Then I'm going to just write out this helper function here, Snowpark Connect, which just loads and establishes our sessions for us. This is what we're going to use throughout as well, just to simplify the kind of session building along the way. You can test that the actual function works here. We just import and use our Snowpark Connect. We get the current warehouse that we're running on. We can iterate through all of our warehouses, get the current warehouse that's gotten bigger, etc., and go ahead and close the session at that point. So that's just some initial setup work that we'll do up front. At that point, we're going to get into the data engineering kind of task here. So as I mentioned, we're using city bike trip data going back to 2013. In particular, we need to build out the ability to ingest this historical data, which has been landed in S3 buckets already. We're going to have to do a lot of cleansing and transformation to make that data usable for our data scientists. And additionally, we also need to set up the infrastructure necessary to have sort of an ELT pipeline so that we can continuously ingest new data as it's made available at the end of each month. So we've got this S3 bucket here, which is where historical data is landed and where incremental data would be loaded in kind of a monthly basis. And the goal here is just to build out the steps necessary for us to have our trips table that has the individual trip record data inside of our Snowflake account. So again, just do kind of standard Snowpark imports as well as some other relevant packages and libraries that we're going to need. We're going to set up our session to Snowflake just like we did before. First thing that we're going to do is create a stage for loading data to Snowflake from S3. So this is typical of any data ingest processes and data engineering tasks on Snowflake. We'll create this reset database function here as well, just to keep things clean for us. You notice we haven't really gotten into the Snowpark data frame transformations yet, but just using the session, you can also write and invoke SQL commands directly from your Snowpark Python client as well. So you're not restricted to just the data frame API necessarily. Anything that you can do in Snowflake SQL, you can do from Snowpark using session.sql, even if there's not a direct API translation necessarily for that just yet. Once we have that clean database, then the next thing we're going to start doing is extracting the files from our S3 bucket that we're going to upload to our stage to actually ingest into our tables. So one thing that's tricky, right, about and this is very common in the real world, is that you might have different date-time formats and schemas and things like that you have to account for across large volumes and significant scale of data when you're working on your data engineering tasks. So here we've got one file name kind of format. Once we got to 2017, they started changing that format of the file name, that sort of thing. So we're going to account for both of those different sort of formats when we upload our files to the stage here. So first thing I'm going to do is use our one of our warehouses to actually download and unzip and then upload the files to stage for temporary ingestion. You can see here that this is where we're downloading from our S3 bucket, and then we're going to put the corresponding trip data CSV file. I'm going to go ahead and upload that into our load stage on our Snowflake account. Once we've done that, you can also list out obviously the files from that stage. You'll see that the two sample files that we've extracted here have been uploaded to that stage. And then what we want to do initially is just load all the raw data as string types. And then we're going to fix all the kind of data messiness and things like that during the transformation stage. What we typically see is this ELT as opposed to ETL pattern for Snowflake customers. So we're going to extract all the data we need to our stages. We're going to load it in a extremely raw format into tables, and then do transformations on top of that to make it usable for our data scientists. So here I'm just defining the two schemas I need. So from over one time frame, we had one particular schema, and then at a certain point in time, the schema changed slightly, and so we're going to have both schemas, and then we're going to define ultimately the target table schema for how we join this data up into a transformed usable format. Once we've got our schemas defined based on the fields in the data, we can use the Snowpark session.createDataFrame method here to create an empty table using each of those two schemas that we defined up here above. We're going to save those as tables. At this point, they have no actual data in them. They just have the schematized tables. You can see, obviously, this is something you could certainly do with a create or replace table type SQL command, but here we're using the Snowpark .style Pythonic syntax to create this empty table based on that particular schema. Once the schemas have actually been created, we can then load the underlying data from stage into the table directly. So much like you would use a copy into command in SQL, we can use our session.read, pass in the relevant options we need around the file format and things like that, give it the stage name where the data is located, and then call a copy into table command for our load table that we just created up here around schema 1. We do the same for the schema 2 type data, at which point we've now got two sample raw data format tables in Snowflake that are populated with just one month each of kind of sample data. So we're going to build out what our transformation tasks need to look like before we'll look at modifying to do kind of bulk ingest of all the historical data, as well as setting up our kind of incremental ingestion pipeline. So since we have this sample raw data loaded, we're also going to do some work to transform that raw data into a more sort of usable format. We'll do the union, of course, on the field names, do some date format cleanup, and then create a transformed data frame that has the fully kind of cleaned up format that we're going to write to our actual trips table. And so this is where you'll see we're doing regex replacement, timestamp conversions, selects, etc. to write our data to table. Certainly, again, this is all work you could do with SQL, but instead, for a Pythonic kind of data engineer, this sort of style syntax and kind of chaining of lazily executed transformations and operations might be a much more familiar and comfortable construct, and also gives you the flexibility to deploy into sort of any kind of production level Python application as well. So we're going to look at it orchestrating via Airflow at the end of this, but anywhere that you could run a Python application, you could end up deploying this as functional code and then running it there as well, which is what we'll see with Airflow here at the end of this demo. And then you can just test. We'll see here we loaded like 2 million or so records here, it looks like, from just our sample data. We're then going to take our schema definitions and the transform schemas and our trip extraction code that we developed up above, and we're going to export this as in a kind of modular functional way, so that our ML ops teams can use it later on for building out the pipeline and orchestrating. Once we've done that, you can also jump into this ingest logic bulk ingest logic notebook as well. Fundamentally, what this notebook is going to walk you through is just using those ELT functions that we built in the previous notebook, testing them out and timing them, and then ultimately doing a bulk load of all of the historical data into our Snowflake account. So what's cool about this is we've written this functional Python code to do data frame manipulations, transformations, table creation, schemas, etc. And then what we're able to actually do is run our bulk ELT function, which is using the Snowpark data frame client code under the hood, and fundamentally ingest about 92 million records, raw records, into a Snowflake table in just over 30 seconds. So you're seeing, again, pretty significant, impressive performance around, just kind of like Snowflake is already known for in terms of performance and efficiency and scalability, but all doing this in a very Pythonic way, as opposed to having to like write native SQL as would have been kind of required previously. So at this point, we've got bulk historical data loaded for our data scientists to start doing some analysis on and model training and fitting and things like that. And then ultimately, we've exported all the relevant ingest and transformation code necessary so that our ML ops teams can run through it later on. The other piece that we're going to do is we're going to pull in some data marketplace, Snowflake marketplace data. So we've got instructions here in the notebooks as well. But you can also, of course, as always, log into Snowsite, go to the marketplace. In this case, our great partners at WeatherSource have produced a climatology data set specifically for this particular hands-on lab in Quick Start. So you can search for Snowpark, pull up this tile. I've already added it to my account, but if you have not added it yourself, you'll be able to click Get Data over here and then specify the Weather NYC name to create this database for you to use inside in your account for your data science needs. So you can imagine for trying to predict bike share demand, certainly weather could have a significant impact on that. Rather than having to create and maintain your own sort of weather reference data sets, you can instead use the marketplace to subscribe to our provider data sets there and have real-time access that you don't have to manage to live and relevant data. We're using weather data here, but if you've not spent any time in the marketplace, I highly encourage you to go take a look at all the different kinds and flavors of providers and data sets that are available to you as a Snowflake customer for free, both in free and kind of paid models. But there's tons of good examples, stuff that came out that was shown at Summit, some very exciting things. So do take a look, explore the marketplace if you haven't spent time with it previously. Once our marketplace data is added to our Snowflake account, we've subscribed to that listing in the marketplace. We're ready to jump into the nitty-gritty of the data science work. So here's what we're going to do, kind of our exploratory analysis and feature preparation, as well as experimental model training. As I mentioned before, initially we've got close to 100 million rows. And for the environments that a data scientist is typically doing this exploratory work on, it's going to be too much data to fit into memory on a local machine or even a reasonably sized single VM in the cloud. What the Snowpark Python data frame API, though, lets us do is, again, build kind of familiar syntactical DAGs of data transformations, effectively, that do 100% push down of the underlying compute for all of our data prep, transformation, and feature engineering to Snowflake directly. As far as like the security elements go for this, we are going to do an in-memory read of a limited set of transformed data for some experimental model training, but there's not going to be any intermediate data persisted outside of Snowflake. And then once we get kind of the code and framework that we want to do our feature engineering and model training, we're going to end up actually pushing 100% of all of that work down into Snowflake directly using both the Snowpark data frame API as well as the server-side runtime, and we'll get into that in one of the future sections here. So as you walk through this notebook, you'll see we'll start off by doing some basic analysis. We're going to do things like getting a daily ride count as we're trying to do a 30-day demand forecast. So we're not, we don't necessarily need all the individual trip level records. We're going to aggregate those up to daily counts. And once we have that, at that point, that aggregated data is small enough we can fit it into memory for doing some visualization and analysis. So we can pull it back, we can plot what those daily trip counts look like over time. You can see that we've got some definite kind of seasonality trends as well as a general linear growth trend. So should have some useful features in here that allow us to do kind of a forecast out of what this similar kind of demand looks like into the future. We're going to do also use the Snowpark's windowing functions and things like that to do partitioning. So initially I'm just going to look at for a single one of our stations. Let's pick the busiest station, for example. That's where we're going to do our kind of experimentation, though fundamentally because we think a model is going to be more accurate if we have a different model for each station, as the station patterns may be significantly different and that sort of thing. That's a pretty challenging task once it comes to production level orchestration and operationalization of training and evaluating hundreds of models. But so what we're going to do is start our experimentation with just a single station. But then when we deploy out into the Snowpark server-side runtime, we'll be able to parallelize this same process across all of these hundreds of different stations to get extremely efficient performance for both training, forecasting, evaluation, etc. So we're just going to do some other, filtering, group by counts, etc., to get the trip count for a particular station that we're interested in here. Do some plotting, look at some auto correlations related to the seasonality. We see maybe there's some lag features across 1 day, weekly, quarterly, and annual that might be of interest to us as potential features. Once we've done that sort of analysis, we can codify a Python function here that uses, again, Snowpark Python data frame type syntax, as well as here we've got like the lag feature calculations and things like that to basically build out our generated features from our raw trip records. And that's going to become our feature generation logic that basically creates that lazily executed DAG of aggregations, which is what we're going to end up incorporating into our pipelines along the way. So if we then, call our generate features function, you'll see we get back for just this one station by day, the count, and then all the lag variables. You might start with doing a baseline kind of train, predict, forecast, plotting kind of process against just that initial single station. We can do kind of baseline, look at what that performance looks like, as well as then do things like pull in holiday level data, similarly do model training and comparison of what the actuals to the predictions look like when we incorporate holiday data. Then we're going to also bring in our weather data from the Snowflake marketplace that we just added previously inside of Snowsight. Once we do that, we're going to use the Snowpark client API to generate the relevant weather features that we need. So we're going to filter on the particular postal code we're interested in. We're going to select the total precipitation. We're going to calculate the average temperature, and that gives us by date precipitation temp. And then we can join that up with our trip level feature and holiday data that we created previously. Once we have that, we'll go ahead and do our model training again. We can plot out what that performance looks like and calculate some evaluation metrics. One thing that's nice is we're using PyTorch TabNet regression model here, which gives us feature importance, which is extremely important for explainability of our machine learning model. So we can also look at that feature importance to determine if there are potentially features that are not useful that we've incorporated that we could also throw out to simplify our model and things like that. You see here that 365-day lag, for example, is not important. Holiday doesn't seem to be all that important either, but we've got significant importance across a number of other features. At that point, we've decided on our final feature set, and so we're just going to consolidate that code that we had before into this, again, kind of functional this functional code where we're using the Snowpark client within that. This is what we're going to pass off to our ML engineer to figure out how to operationalize in a useful way, basically. And so we've got our holiday data frame generation, our weather data frame generation from our Snowflake marketplace, share listing. We've got our trip level feature generation to do our lag calculations, etc. And then at the very end of this notebook, we're going to train and evaluate the model with our final feature set for just that one busiest station. And this is the last point in time where we're going to do any sort of in-memory computation really as part of this. So then we have, again, what our model performance looks like, and we've got feature importance as well. At this point, we've created the ELT logic to bring in this data. We've done the kind of data cleansing and prep needed to make this useful for our data scientists, as well as exposed reference data from the Snowflake marketplace to our data science team. The data scientist has done their exploratory work to determine what features are interesting for predicting this. They've built out the functions necessary to do your training, predictions, forecasting, etc., and evaluated that against a sample station. And the question now is, how do we kind of scale this out and operationalize it to run across the potentially hundreds of stations that we're interested in making these predictions for? And that's where the handoff to your ML engineering team might happen. Typically, right, what we would see is that a potentially data scientists don't always have the software engineering expertise to hand off an extremely usable kind of format of their work to a software engineering or an ML engineering team to actually figure out how to deploy and make useful. Because Snowpark Python it's just a Python client library, the same sort of library that the data scientist uses to work with that data in Snowflake can just be handed directly to your ML engineering team to figure out how to productionalize and put into a kind of full operational pipeline. So we're going to take the functions and the training inference definitions from our data scientists. We're going to put it into production using the Snowpark server-side runtime. So even before where the data scientist was invoking this code from their client, even though the pushdown was happening to Snowflake directly, we're going to actually deploy and orchestrate the complete kind of set of functionality into the Snowpark server-side runtime using Snowpark UDFs for ML model training and inference. They're first going to just start out by exploring what the feature pipelines sort of look like, make sure they understand the tables, how they get materialized, everything like that. Also write a function that creates the forecast features for the forecast horizon that we're interested in. So that's going to take the forecast weather from our Snowflake marketplace listing, as well as the historical data, pull in holiday level info, build out the dates, the lag features, etc., all that kind of stuff. At that point, we have now a forecast data frame that we can actually work with. So the other piece we talked about is wanting to parallelize the model training, inference, and evaluation across all the different stations. And Snowpark allows us to do that by actually using our window functions to partition across those stations and then registering the relevant training code as a UDF that's partitioned by those stations. So each station sort of gets looked at and models get trained and inference occurs in isolation in parallel to each other. And what this allows us to do is create, for example, the feature set for every single station that we're interested in under 2 seconds, which is, again, that's happening across hundreds of different stations, as well as close to 100 million raw records that this is all being generated from, and we can do that in under 2 seconds using the partitioning to parallelize out across our virtual warehouse. The next thing we want to do is take the train predict function that our data scientist that built for us and deploy it into Snowpark server-side runtime as a Python UDF. Because we're doing sort of a time series prediction here, where each month we're gonna retrain and update a forecast, we're actually gonna do both training and inference inside of a single UDF, because we don't need to save the actual model artifacts themselves. We're gonna save the predictions into like an output predictions table, and then link that to our input training data, but we don't need the actual model artifact. And so we can have this single function that takes in the historical data as well as what the forecast kind of period looks like, generates all of our features, does a train test split, and then does model fitting, and then outputs the model predictions over the forecast period to be persisted into a table. This just looks like what you'd expect kind of your train test split type code and then model fitting to look like. Once we have that functional code, we can deploy that into the server-side runtime using a session.udf.register. The important thing here is that we're also able to specify dependencies of our particular code. So we're using things like PyTorch and scikit-learn and scipy throughout our functional code. Snowflake has a partnership and integration with Anaconda, where we have a Snowflake-specific channel for Snowpark Python usage that is owned and maintained and supported by Anaconda. So everything listed here is available to the server-side runtime out of the box to be used. And there's some, 1,500 plus packages. You can always request additional packages be added via the Snowflake community page. But this is all natively available to you both as a developer in your own client environment when you're building for Snowpark Python capabilities, as well as available to your server-side runtime. So when we register our train and predict function as a UDF, we specify the relevant dependencies, which Snowflake then uses our Anaconda channel to ensure are made available to our code when it actually executes inside of the Snowpark server-side runtime. Now that we've registered that as a UDF, we can test it out. And you can see here where we are testing out a 365-day forecast across all 600 plus stations that we're working with, where we're doing model training and evaluation, model training and prediction out over a 1 year period. We can run that for hundreds of stations in parallel in under a minute. Which is significant, and that's certainly a task that typically there might be a lot of kind of overhead and maintenance involved with figuring out how to distribute all that workload. But Snowpark Python kind of does it automatically for you. You can then also do things, like query out the prediction. We want to do some calculations of what our predictions versus actuals look like for certain stations and things like that. You might also want to further define a more kind of complete evaluation function where we take the previous predictions with our new actuals and do that could be the kind of performance metric calculations and store that data into a table as well. Much like the same way that we parallelize the station model training and inference, we can parallelize the model output evaluation in the very same way, and then deploy that same evaluation function into the Snowpark server-side runtime as a UDF as well, much in the same way before, where we have our eval model Python function here. We call session.udf.register on that function, specify some parameters that we need, as well as our package dependencies from Anaconda. And then that code is made available inside of Snowflake to run natively. So then we can actually test that out. We can take our test predictions and then call our evaluation UDF against those test predictions, and then save the evaluation metrics into an eval test table. We can then show what that eval test data looks like. So here you're seeing, again, hundreds of different stations, all being trained and forecasted for in a parallel, scalable way over 100 million historical data points, and then doing a parallel model evaluation of our historicals versus our actuals versus predicted values, all inside of Snowflake compute. There's no actual in-memory computation happening in my engineer's client environment. Everything that they're calling and actually running is executing inside of Snowflake to test this out. Once you actually have the training, prediction, forecast, eval functions all put together, we're just going to create some tables that then take the resulting prediction, forecast, and evals, and then parse the data out a little bit for us to make it a little cleaner and easy to use. And then we're going to take the relevant functions that we have here that take us, step by step incrementally through our pipeline, and export them in a functional way to be deployed into our orchestration framework. So here you have our, weather data and holiday data materialization. You have our function for deploying our prediction and training UDF, as well as our eval UDF. We have the function for creating our forecast table, for creating our feature set, for doing train predict, evaluating the models, finding the tables, etc. Once we have all of that exported, our operations team can then use the same exact Python code, the Snowpark client code, to orchestrate the actual automation of this sort of pipeline with full push down of everything into Snowflake directly via something like Airflow. So here we're going to use Airflow directly. All we have is the ML ops team pulling in the relevant functions that our ML engineers exported, just testing them out, making sure everything works. Then you can consolidate the sequences of these functions effectively into these tasks, which can then be decorated with the Airflow task flow decorators and DAG decorators to actually be deployed into Airflow directly. So as we build out these sequences of tasks, we then have our DAGs, which again just call the kind of order, identifies what the order of tasks are. Airflow will then actually orchestrate, automation and management of running these. We have both our initial setup pipeline, which includes the database setup, as well as our incremental monthly pipeline, which just is designed to just do the same sort of work, but only on our incrementally uploaded data. We can then test out the actual task flow itself. You'll see here we were able to run the full kind of setup. We do setup, feature engineering, model training, model forecasting, evaluation, etc. Do all of that in just under 3 minutes for hundreds of stations across 100 million different records. Pretty impressive. We just go ahead and test that for a number of different time periods as well. Fundamentally, what that allows us to do then is from our, if we go into our task flows, let's see, here there. You'll see then once we've taken the functions that we created and we decorate them with these, these Airflow task decorators, and then also our DAG decorators on the monthly and setup pipelines. What we can then use is a tool like Astronomer. Great partners at Astronomer provide a managed Airflow sort of environment to then actually launch our DAGs to run in Airflow. And you can see here where we've got our setup pipeline going from database setup to our weather subscription, our initial data bulk loading, our holiday table materialization, feature generation, the deployment of our model UDF, bulk train predict, evaluation of our UDF, the evaluation of the UDF, the model performance per station, and then our metrics and output flattening. All this stuff fully orchestrated as a DAG where you have all the relevant dependencies and ordering and orchestration of this happening automatically for you and managed by Apache Airflow. But importantly, all the actual code associated with each of the components within this DAG is running Snowpark Python under the hood and doing 100% push down of the computations associated with all of this work into Snowflake directly. The next step and final step here is we want to provide a way to visualize and explain the output of our model. And that's where Streamlit comes into play. So I'm sure you heard earlier in 2022, Snowflake actually acquired Streamlit, and then we demoed some very exciting new upcoming capabilities related to Snowflake and Streamlit at Summit back in June. Today, you can get started with Streamlit right away using the open source library. And that's exactly what we've done here is where we've written simple Python code to create a web application front end using Streamlit on top of our MLOps pipeline. And so our Streamlit app, using just 100 lines of code or so, we get an application where we see for each of our top stations, or for the stations that we choose over here on the left hand side, you'll see the daily forecast for your forecast window, which is the number in the box here. You'll also see highlighted, and then in the tooltip, the explainability behind our models. So we have for the core for each of the features that are used in our model training, you'll have the color will dictate what the most important feature was for that station for that day's forecast. And then if you hover, you get in the tooltip the explainability of the feature importance across all of the features, which is pretty important. As well as then we get for our various runs, we are visualizing our model performance metrics as a way to kind of monitor performance over time. You also have the ability to, of course, add buttons and things like that can actually trigger ingest tasks and things like that. So, on the first of the month, you could run your ingest task flow for that new month's worth of data or something like that, and have that all controlled and made available inside of a Streamlit application. Again, where all of the actual computation and everything that happens, all the work that's actually being done on this data is pushed down into Snowflake directly. So that is a ton of material, but that covers the kind of end-to-end sort of ML pipeline possibilities with Snowpark Python today. And we didn't even get to explore things like Python stored procedures and table functions, which further kind of enhance and expand your ability to build these sort of ML capabilities on top of Snowflake. So once again, if you'd like to go back and revisit this and kind of work it at your own pace, we have the Machine Learning with Snowpark Python Quick Start available on quickstarts.snowflake.com, where you can go and walk through all of this code yourself at your own pace and kind of see what the full end-to-end picture looks like for yourself. Hopefully you're just as excited about Snowpark Python as we are, and I look forward to hopefully running into and working with many of you in the future.
Thank you, Caleb. And so I hope you guys really, like I mentioned at the beginning, got a better grasp of how you can use Snowflake for data science and data engineering, how you can run your Python code next to your SQL code and combine the two to make it really easy to both build, orchestrate, and operationalize your data pipelines and machine learning workflows. And then, of course, be able to do that for your own use cases, leveraging any of the components in the Snowflake platform, whether it's using SQL or Snowpark, which has those different components, which are the UDFs, the API, and the stored procedures. I think there's only so much that we could show today, and so there's a lot more that we can show you around how to use Snowpark along with any other features that are available for our developers. And so what I want to do is invite you to register at snowflake.com/build for our developer conference, which is happening in November, where there's going to be 2 days worth of 20 plus sessions and hands-on labs from builders, both from our company, customers, partners, that are going to show you all the things that you can do with Snowflake. And of course, check out if maybe there's a local event near you that you can attend. And with that, I want to say thank you to everyone, and let us know if you have any questions.
That was great. Thank you guys so much for your presentation. And if there are no additional questions from audience members, I think that's all we have. Thank you to our audience for joining us, and thank you again to Caleb and Julian. Hope you guys have a great rest of your day, and as a reminder, the webinar will be available for on-demand viewing in about 24 hours. With that, I think we're all wrapped up.